James Clerk Maxwell, best known for his Maxwell's equations, is reputed to have set things straight with his theories of electrical properties in a way that eliminates zero-point energy. But Maxwell's more advanced work allowed for the existence of an ether, a substance finer than air, which since the time of Plato had been considered a scientific fact.
The prevailing belief of the time was that the vacuum was a thin material fluid, the so-called material ether, which we know today is false. The ether is there, but it's not the observable material fluid. Faraday had re-established this notion of lines of force, but he thought the electromagnetic field or the electromagnetic disturbances in the ether, so to speak, was really twanging strings. The strings were under tension, and when you had a disturbance, what you really did was pluck the strings. Now, Maxwell states very clearly that he set about to actually capture exactly what Faraday was doing in his lines of force in the theory, and that's what he did. Maxwell's actual theory is 20 equations and 20 unknowns in quaternions, which is a higher topology algebra. You can do things in that you can't dream of in doing in tensors, and you certainly can't do in vectors, and you certainly can't do with the theory that's taught at our universities. All that remains to be rediscovered and uncovered.
The now famous Michelson-Morley experiment at the turn of the century failed to detect a stationary ether, so classical physics presumed once and for all that it did not exist. The case was closed until quantum mechanics reopened the discussion, allowing for a new interpretation of how matter interacts with a zero-point field.
Most of our scientific community actually believes that empty space, the nature of space itself, is completely empty, devoid of anything. And historically, it's very interesting because in the 1800s and even earlier, they believed there was an ether, an all-pervading substance filling up space. And in 1905, when relativity theory became very popular, they said, well, we don't need this ether. Empty space is empty. Then 25 years or 20 years later, in 1925, when quantum mechanics comes into play, all of a sudden, a new energy appears in equations of quantum mechanics, and it has to be there to make the equations work, and it has to do with fluctuations of electromagnetic field energy at a very high frequency that interacts with everything. And they called this the zero-point energy, and it turns out that all the elementary particles interact with this energy, and it becomes a potential energy source. That's what we're discovering today.
Well, free energy is basically, and another word for it is zero-point energy. It's energy that is contained within the vacuum of space and which is virtually undetectable by any traditional means. In fact, the energy is homogeneous and isotropic, the same everywhere, the same in all directions. And because of that, it's trying to extract it or measure it is sort of like the problem of trying to weigh a beaker of water underneath the surface of the ocean. What do you measure with respect to what? And that's been the physicist's dilemma, and we've gone down one very large cul-de-sac this century. The cul-de-sac meaning that there is no such thing as consciousness. There is no such thing as this zero-point field, or this place from which the energy can come. And the answer now appears to be yes, because theoretical physics and a number of experiments in quantum mechanics show very clearly the existence of this all-pervasive electromagnetic field called the zero-point field.
In fact, although skeptics often point to Einstein's theory of relativity, it was Einstein who in 1920 said,
"There are weighty arguments to be adduced in favor of the ether hypothesis. To deny the ether is ultimately to assume that empty space has no physical qualities whatsoever. The fundamental facts of mechanics do not harmonize with this view. According to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable."
The term vacuum has been used in several totally different senses. Some engineers use it to mean you just pump out all the air, and that's called a vacuum, and that's vacuum technology. That's not what we're talking about. We're talking about empty space-time. We know today, for example, the Lamb shift in quantum mechanics showed that this exchange of energy between the vacuum and the charged particles is in fact real and generates real effects. And you can measure it, and he was given the Nobel Prize, Lamb was, for doing that kind of measurement and showing it in the physics literature. So we know it's real. Experimentally it's detected. The Casimir shift, for example, shows clearly that it's there, and it does generate energetic effects in your actual materials. It turns out that in the modern view, the modern quantum mechanical view, if you apply that knowledge that's been gained there, what you find is that the vacuum is fiercely active. It's a fierce energy flux and going in all directions at all times. The energy density of that, as estimated by various physicists, is extremely high. For example, in 1 cubic centimeter, if you could take the raw energy in that cubic centimeter and condense it into mass, divided by c squared, you would have more observable mass result from that than our largest telescope can see in the observable universe and all the stars and planets today. And so the energy that's there is extremely dense and extremely fierce. This drives everything that we call physical reality, from the quantum level right on up to the observed level and the observed world that we live in. Everything is energetically driven by the vacuum.
At the turn of the last century, Nikola Tesla, the great inventor who gave us alternating current and the Tesla coil, stated,
"Electric power is everywhere present in unlimited quantities. It can drive the world's machinery without the need of coal, oil, gas, or any other fuel. This new power for the driving of the world's machinery will be derived from the energy which operates the universe, the cosmic energy."
With over 200 patents to his name, Tesla was well on his way to transmitting electric power without wires when he ran into trouble with J.P. Morgan and the financial interest of 1901. His ambitious Wardenclyffe project to magnify and transmit power to ships at sea and eventually to provide free electricity for the whole world was scuttled by Morgan, leaving Tesla penniless and disillusioned. The wealthy industrialist of the time knew that their vast plans to wire the world with copper from the mines they owned would be upset if they could no longer control the supply and means of delivery. Tesla's beliefs about developing technology in harmony with nature conflicted with the prevailing American attitude at the time that mankind was put on Earth to subdue and dominate nature. Little by little, Tesla was denounced as a crackpot and deleted from the historical record. At the time of his death in 1943, Tesla's truckloads of scientific papers were seized by U.S. government agencies. Who knows what ideas and remarkable devices our world could have inherited if only his genius was recognized.
When J.P. Morgan prohibited Tesla from broadcasting electric power overseas with Wardenclyffe Tower, he said, "I can't put a meter on it, therefore I won't finance it." That literally changed the course of history, and for the past almost 100 years, we've been suffering under that profit motive